morning, students. So this is a course that we are starting, Programming in Java, Problem Solving Approach. So we are starting with the very fundamental things, and I'll start with computer system itself rather than starting from Java directly. So I'm starting from the computer fundamentals. So for programming, if you want to define what is a computer system, so it's a kind of very simple definition. It is a system which consists of CPU and RAM, and then we have hard disk, and then monitor, and one last thing is a communication device. So computer system is nothing but is a combination of CPU. The most important part is the CPU. Then we have the RAM. I have purposely written a RAM, which is random access memory. Then we have the permanent memory. We have some output devices. So generally it is a monitor, but it can be a printer also. This is the output device, and this is the input device. So generally the input device is a keyboard, but we can have a mouse also, and you can have a pen also as an input device. And what is a communication device? Communication device, it's an interfacing device. For example, a LAN card. Yes. And then what is a storage device? A storage device is a permanent memory, and RAM is the fastest memory which directly communicates with the CPU. So one by one we have to understand these units, because these units are very important for the programming. And every a program, uh, these components is having a specific a specific a role in every program. So I'll start with the CPU. So CPU is what? It's a brain of a computer. That means all the computation which are happening, it will be executed, or it will be performed by CPU only. It's like a brain of this computer system, and it is the most important component. And when I'm saying a CPU, so don't please think of a cabinet. If somebody is using a desktop, so it's not a cabinet that I'm talking about. A cabinet looks like this. Yes, so in older days, right now all of you are using a laptop only, but in older days people used to have this kind of a desktop in which a cabinet is there, and generally people used to call it a CPU. Students, this is not a CPU. CPU is a chip, okay, and it is identified like this, and it's a brain, and where all the computation starts, and where all the computations, you can say, or the executions actually happen. So one thing about the CPU is very important, and that's the speed of a CPU. And when I say a speed, so you must be very, very clear what I'm talking about. Okay, speed of a computer. And speed, generally you can define like this: speed, and I'm talking about the speed of CPU. The meaning is that how many instructions, okay, how many instructions, okay, allow me to write how many instruction it can execute. It can, I mean, CPU can execute in second, So there are some units. For example, hertz is a unit, and then kilohertz is a unit, and then megahertz is a unit, and then gigahertz is a unit. So generally when you buy a CPU, or when you buy a computer, you see the computer system I'm talking about, you see a configuration, students, and here you will find like 3.2 gigahertz, okay, and you may also find 2.4 gigahertz with other combinations. So this is about the speed. So we are trying to decode this word. What is the meaning of gigahertz, what is the meaning of megahertz, and what is the meaning of kilohertz, and where does it stand? So if the speed is 1 hertz, so that means it can execute one instruction in 1 second. It's just the opposite of what? A second. So hertz is a unit of frequency, by the way, in normal physics. But when we take it in this electronics part, what it will become? 1 hertz means what? One instruction in 1 second. Can somebody please think of what is a kilohertz then? So kilohertz means, if the speed is kilohertz, then I would write like this. Uh, uh, Directly I should write it: 1,000 instructions in 1 second. So if the speed is kilohertz, 1 kilohertz, that means it can execute 1,000 instructions in 1 second. And what about the megahertz, students? So if the speed is megahertz, then obviously now you can figure out 1,000 into 1,000. into 1000 instructions in 1 second. So if you write it this kilohertz, it will be 10 to the power 3. And if you write this word, it would be 10 to the power, yes, anybody? 6, 10 to the power 6. Then what is the meaning of gigahertz here? So gigahertz here is how many times? 3 times. 1000 into 1000 into 1000 instructions. That means what? 10 to the power 9 instructions. That means a billion instruction, 1 billion instruction it can execute in 1 second. So that's how we measure the speed of a any computer or speed of any CPU. Why it is important? Because we are going to calculate the actual, a time complexity. Okay, one is relative time complexity that we measure in order of n, an order of n square, an order of log n, order of n log n. But when we do the actual experiments, kids, so their actual speed we have to measure, and that speed comes in these units, because the speed is actually how many instructions it is executing in 1 second. So hopefully it is making a sense at your end. Now the second important unit is memory, and memory is to store the data. Okay, and when I say a memory, so think about this chip in your mind. And when I'm saying a memory, so generally I'm talking about a RAM only. Okay, random access memory, which communicates with the CPU, and this is the area where our program resides, where our programs are loaded. Doesn't matter any language. Okay, all the programs are loaded, you can say, in a RAM, and from RAM CPU extract, in very simple words, there is a technical term for that, but CPU actually fetch the program from the RAM and then it executes. Then what is important about a memory? The CPU is governed, let me write it. CPU, whenever you heard, you have to think about speed. Okay, and when you talking about a RAM or a memory, yes, space. We are talking about what? Space. So these two things must be very clear at your end. So when we are talking about space, so space are like this, space are like this in terms of bits and bytes. Okay, in terms of bits and byte. So the smallest, you can say, a unit, just like there the smallest unit was what? Hertz. Okay, let me say this way. Here the smallest unit is what? Hertz. And here the smallest unit is what? A bit. We are talking about a bit, but we have to understand all the I always say bits and bytes, and now the topic is also bits and bytes. So the smallest unit of data in computer obviously is a bit, and bit can have a value of either 0 or 1, 0 or 1, and it is, that's why it is related to like electronics, because if you have a one cell, okay, and that's a bit, so either you can store a 0 or you can store a 1. There are only two possibilities, but behind the scene, for 1 there is a voltage, and for 0 there is no voltage. So it is like, making some kind of a number system, or it is making some kind of a language, and the language is a binary language. Then there comes a group of bits, and group of bits generally, not generally, it is always 8 bits. So 1, 2, 3, 4, 5, 6, okay, 7 and 8. So 1, 2, 3, 4, 5, 6, 7 and 8. So these are 8 bits together, and that is called byte. But one important point, and that important point is whenever you are reserving any space. Yes, whenever you are reserving any space in a memory, you cannot reserved by bit. Yes, by bit. Minimum amount or a minimum unit is what? A byte. So further, the bytes are, you know, uh, we can maximize it, or we can use some other units also. For example, kilobytes. And here, students, we are multiplying by 1024. So if you are making byte to kilobyte, so we have to multiply it by what? 1024. It is not 1000. We are not multiplying by 1000, rather we are multiplying by 1024. Okay, so how many bytes kilobyte is having? It's 2 to the power 10, because we have to work in 2 to the power order. Then there comes like kilohertz, we have a kilobyte. For megahertz we have a megabyte, and then for gigahertz we have what? Gigabyte. But just remember that here we are multiplying by 1024, and it is very close to the 1000, and it is in an order of 2 to the power 2 also. Okay, and How the data is stored in this, because this is like 1 bit, okay, and this is like 2 bits, and this is like 3 bits. So here what I'm talking about here, this is 4 bits. So if you have a 1 bit, how many options you have, kids? You have options 0 or you have option 1. But can somebody tell me, if 2 bits are there, how many possibilities are there? So the possibilities are 0 0 0 1, and then 1 0, and then 1 1. If I'm making all the combinations, so these are the all possible combination if you are using 2 bits. Then what we have is a 3 bits. So how many possibilities are there? We'll start with 0 0 0, and then 0 0 1, and then we can have 0 1 0, and then we can have 0 1 1. If I'm not missing anything, then it will become 1 0 0, then 1 0 1, and 1 1 0, and then last is 1 1 1. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. Yes, 8 possibilities are there, and I made all the combinations. So if you have observed that here it is 2 to the power 1, here it is 2 to the power 2, here it is 2 to the power 3. So if you calculate it, how many possibilities are there? 1 2 3 4 5 6 7 8, and 2 to the power 3 is what? Nothing but 8. Can somebody tell me here? It is 2 to the power 4. So how many possibilities are there in this case? 16 possibilities are there. Likewise, if you are going with 8 bits, 8 bits, like this is 1, this is 2, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. So let me calculate it for 8. So how many possibilities are there? 2 to the power 8, and I think it will come out 256. You can confirm it from your calculator also. So these number of possibilities are there. Why we are learning them, and why I'm telling you so much basics, because you have to learn a data types, and data types takes space, and the space is governed by this law only, how many bits it is taking and how many bytes it is taking. So if you know that how many bits and how many bytes it is taking, doesn't matter you are learning Python, you are learning Java, you are learning C or C++, immediately you can figure out the range, the space, and all the things you can figure out. So one question I have in a memory, first I'll take from the memory, and the question is very generic. Okay, in a programming language X, so we have a programming language X. If the certain data types takes 3 byte of memory, yes, 3 bytes of memory, then how many maximum possible values it can store? So pause this, I'm continuing this. So you pause this and think of how many possible values it can store. So 3 bytes, if you start with, students, 3 bytes, so it would be how many bits? It would be 24 bits, right? And for 1 bit it can take 0 to 1. For 2 bits it can take, I have just made the combination, so here it is 2 to the power 1, here it is 2 to the power 2 for 2 bits. Okay, and for 3 bits it is 2 to the power 3. So what about 24 bits? So it can take 2 to the power 24 possible values. And if you calculate this 2 to the power 24, I have already calculated, the figure will come out like this: 1,677,772,116. That's the value when you compute it, 2 to the power 24. Now this figure is telling lot of things. So if you are starting from 1, your numbering system, so maximum value it can take this. But if you are starting from 0, so maximum value would be what? 215, not 216. And if you are starting from minus numbers, so you have to divide this by 2, and whatever the value is coming, you have to take this, then 0 will come, and then the positive values will come. What I mean is, if you are taking a negative values also, let me give you a very simple example. Instead of 3 bytes, yes, instead of 3 bytes, let's say the programming language takes 3 bits. Yes, 3 bits. And you have to take a negative values also. So what is the minimum value? What is the maximum value? You have to figure out. So let me start this. 2 to the power 3 is what? 8 values. And if you divide by 2, it will become what? 4. So minus 4 you have to start, then minus 3, then minus 2, and then minus 1. There comes a 0, then 1, then 2, and then 3. So you are not going up to 4, you are going 4 minus 1. This 3 is what? 4 minus 1. If you count the value 1, 2, 3, 4, 5, 6, 7, and 8. So 8 values we have taken. So similarly, I'm talking about if you are taking or if you are considering the negative values, so here you have to divide it by 2. I hope this is making sense at your end, and these type of things you can solve it now. Just keep it in mind. This figure, this diagram, you have to keep it in mind. Starting from 1 bit, 2 bit, just straight away you have to put 2 1, 2 2, then 2 3, and then 2 4, straight away up to 2 to the power 8. We have one more exercise, then we'll finish. And this is like my real exercise. I made it, and actual data is also there. When I started my computing and when I started my programming, I started with a CPU, and the CPU model, or you can say, was Intel Pentium 4 with a speed of, and generally it is referred as a clock speed. It is still mentioned, and I have the manual with now, and I'm talking about 12 years back from now, but it is there. The speed was what? 3.4 gigahertz. So can you calculate the maximum number of instruction it can execute in 1 second? Okay, I hope it is not a problem. So let me, I have calculated at that time. Now I'm recalculating, and let's figure out whether my solution is correct or not. So if, a 1 hertz speed is there, 1 hertz speed is there, then one instruction. Yes, if 1 kilohertz, then how many instructions? 10 to the power 3 instructions. And if 1 megahertz, then how many instructions? 10 to the power 6 instructions. And when I'm saying instructions, that means in 1 second it can execute that number of instructions. And then for 1 gigahertz, it is 10 to the power 9 instructions, right? Then it is saying that it is not 1 gigahertz, it is 3.4 gigahertz. So then I need to multiply it by 3.4 into 10 to the power 9, and just this figure 10 to the power 9 is billion. For million we have 10 to the power 6. So how many instructions my old CPU can execute in 1 second? 3.4 into 3.4 into 10 to the power 9, 3.4 billion instructions it can execute in 1 second. See the speed of CPU. You will be amazed by modern CPUs, and even you will be amazed by our older CPUs also. And if you just want to know about the journey of the CPU, and I said it is Intel. Okay, just for your fun thing and just for your information, the Intel started this thing, as far as I remember, in 1971. They have produced one processor called 4004, and the speed, if I'm able to recall it correctly, it was 740 kilohertz. So remember, I'm talking about 1971. The processor name was, here it is Pentium 4. The processor name was 4004, and the speed was 740 kilohertz. Then they went on working on that. In 1974, they come up with very standard processor 8080. Okay, 8080, and for this the speed they have increased to 2 megahertz, 2 megahertz. And in 1976, just you have to rely on my memory, and you have to cross check it also. They have come up with 8086, and the speed, if somebody can imagine, was 10 milli 10 megahertz, 10 megahertz. So this way the Intel has started their journey, and now they are using i3, i5, i7, and i9. So I'm giving you one exercise, and you can put it in comments also. Just find out your CPU, find out the speed of your CPU, and then find out how many instructions your CPU can execute in a second. That way you will understand the CPU part.